Guys, welcome back to my channel, and this is our second part of our plan tutorial, and this tutorial is about clearing your tool test. So if you haven't watched the first part of our plan tutorial, then please complete the first part and then you can join the second part. So let's get this video started. So guys, this is the model which we had created in our first part. So here we have the equipment, the three pumps and the structure. So we have to do the pipe routing for these three pumps which is getting connected to this suction line. So we will be just modeling the suction line and not the outlet, as this is just an overview of our plan 3 tutorial. So in the future videos we'll be getting into details of the pipe routing. So first, to route the pipe, we have to go into home, and we have options like pipe route. So for pipe routing we deal only with this section, and this section is for equipment modeling and pipe support and etc. And next we'll be doing the isometric extraction, which for that you have to go into the isos. So first let us just get started with the pipe routing. So here we have our PNID which we have to route, and this is the suction line and this is the discharge line. So in the suction line, what I have to do is I have to route this single line to this equipment, and this line we can just copy for the other two pumps. So first what I'll be doing is I'll be routing this line which is getting connected to the pump. So first I'll start with the suction of the pump, and we have a 12-inch line here, and the pump suction nozzle is 10-inch. So yeah, it started from the center of the pump, center pump, and this, as you can see, is 10-inch. So what I do, I have to first select the spec, as we don't have any specific spec specified for a project. I'll be selecting any random spec from here. So what I'll do is I'll select this CS150. You can select any other spec, and if you're generally dealing with some company, they will have their own spec. So first it is 10-inch. 10-inch is 250, and I'll route the line. Route line, select node. Okay, there is, see, as you can see, if you see here, we are getting message that can't find flange. So we don't have a flange of size 10-inch in this spec. So what I'll do is I'll change the spec to maybe SS150. Let me check with this. So again, route line, node. Okay, we don't have in this as well. Okay, probably let me just check this. Okay, the flange rating is 300. Okay, so 300 rating, node. Yeah, now the flange is created. So what I'll do is I'll create a pipe of 1D, that is 250 first, and then I'll place a reducer of size 10 by 14 inch. As you can see in our PNID, it is 10 by 12 inch, and we know that in suction we need to have a eccentric reducer. So I'll go here, reducer, eccentric. I need 10 by 12 inch. So 10 is 250, and 12 is 300. 250 by 300. Okay, I'll double click and it will come here, and I place like this, and the flat side comes on the top side. So yeah, so let me check. Yes, perfect. We'll route the line, and let's just give another 300. Okay, so our next component which is coming is the drain. So let me just increase it to 500, and this length I have made it as 500. So in the center I'll be putting the drain. So the drain size, it is 3 by 4 inch with a gate valve. So what I'll do, 3 by 4 inch is 20 20. I'll route from the center. I'll take around 500. Okay, sorry, it has taken the vertical direction. So to change the plane we have to press P and enter, so it will change the plane. So I'll take 500. 500 looks too big, so let me just take around 350. Okay, yeah. Now I have to change the plane, so I press P. So another 200. Let me check in the top view. Okay, I have to increase this by 200. So I have a gate valve now. Okay, I'll just take this butt weld gate valve, insert in the model, and node, enter. Okay, and I have to rotate this valve by 90 degrees. So I have to click this valve, and we have a dot, circular dot here, so that if you press we get the rotate option. So you can select whichever direction you want the hand wheel to be. Okay, and I have to move this valve by another 200. So I'll click this valve, press the center dot, I'll press 150. I think 150 is enough. Yes. So here we have our drain ready. So let me just route another 50 and change the plane by another 50. Yes. So this is our drain, and our drain is ready. So next component what we have in our line is a gate valve and a spectacle blind. I think we don't have a spectacle blind in our spec, so I'll just put a gate valve of size 12. Let me just select a gate valve from our spec, gate valve of size 12. I'll take this butt weld 300, insert in model. So I'll just click here and select the direction in which I want the hand wheel. So here in this case I want in the top direction. Yes, it's perfect. So save it. And next component which we have is a reducer of size 12 by 14, and this is a concentric reducer. So I'll just put a spool size of 250 1D here, and then we'll put the reducer. Reducer is of size 300 by 350. So let me get into this reducer, a concentric 300 by 350. Okay, here we have the concentric reducer, insert in model. No, yes, and enter, and we have placed the reducer. Save it. And next the component which we have is an inline strainer. And inline strainer, since we don't have in our spec, I'll just place 2 flanges in this space. So I'll put around 1D of this, or maybe under 250. Yes, I'll just place 2 flanges. So we will consider that as an inline strainer. 2 flanges of size 350. Else we can just pick the flanges from here. Socket well, okay, well neck flanges will place. Okay, we'll consider this as a inline strainer. Since we don't have many things in our standard spec here, we are just using it. But when you are going to company, you will definitely have all those components, so you have to place the respective components in that space. Okay, after the inline strainer, we have this valve, 14-inch valve, which is connecting to the tank. So let me first route the pipe from the tank. Okay, we'll just directly connect to this node. We'll accept it. Okay, and we'll place this valve here on this vertical line. So what type of valve is it? it is a gate valve of 14-inch size. So gate valve, we'll take this size 350, insert in model, and we'll just select this somewhere in the line, point somewhere in the line. As you can see, this valve's handles are very big, so it's okay for now. So guys, as you can see, we have finished routing our main line. That is, as you can see in this PNID, we have the center main line connecting to the middle pump, and we have other two lines that is getting branched, and the same set of line gets copied to the other two pumps. So what I'll do now, I'll skip this point, I mean two lines. You can do it in your system if you want, like you have to just place one T and copy the same line to the other two pumps. So I'll be skipping that part. So what I'll do now is we'll start with the isometric extraction. And before starting the isometric extraction, we have to give a line number to this line. So giving line number, we have two methods. Either you can give the line number before routing the line, or you can just select this line. I'll click any component here, right click, add to selection. I'll select all connected parts, so whole line gets selected. So what I can do is I'll open the properties and line number, and you can see here, if line tag number, I'll press expand this and press new. If I press new, I'll get the line tag. I'll just give L001 and assign, and get, as you can see, if I select any component, the line number shows up. So we have assigned the line number here, and in the second method, as you have to go here, you have to click route new line. You have to give the line number and then start routing, and it takes on, the line will automatically take the same line number. Okay guys, so let us now start with our isometric extraction. So for the isometric extraction, first you have to click on this name isos. Here, if you click isos, you can see all the components, I mean functions, which are required for the isometric extraction. So here we have quick ISO, production ISO, which we'll be using, and we have this breakpoint, start point, location point, insulation, and flow arrows. So start point is used when you want to indicate that you want the ISO to start from some specific point. For example, I want the start point to be this discharge of this nozzle, so I'll press the start point and select the nozzle, end of the nozzle. So I have placed the start point here. So this is my start point. So, and next, breakpoint. Breakpoint is used when you want to break these spools, break this full line into two spools. For example, I want this spool from this discharge nozzle till this end of the elbow in one sheet, and the next rest of the spool in the other sheet. So what I'll do is I'll select this breakpoint and select the point where I want to break the spool. So this will be my breakpoint. So right now I don't want a breakpoint. So next, location point. Location point is used when you want to indicate some location of some point. What you have to do, just select the location point and click the point where you want the location to show up in your isometric. So next, insulation symbol. Insulation symbol is used when a line is off. If the line is insulated, you can show this insulation symbol. Next, flow arrow. Flow arrow is to indicate the flow direction in the isometric sheet. So our flow is from the discharge of the nozzle to the suction of the pump. So I'll just this is okay for me. What I did is I selected this flow arrow and clicked on the line. So it is asking to accept or reverse. Reverse in the sense it will reverse the direction. So I don't want that. So this direction is okay for me. So next, floor symbol. Floor symbol is used if a line is crossing the floor. In my case, it is not crossing the floor. What I have to do is, if the line is crossing a floor, you have to just place a symbol on that floor level on that line. ISO message. If you have a specific message that has to be read on the ISO for that specific line, you can use this and type your message here and just select where you want to display the message on the line. And next, let us just extract our ISO. So now first we'll do a production ISO. in production ISO, what I have to do is I'll click this production ISO, and here we have a number of if I have hundreds of line, you have all the numbers displayed here. So as I have only one line, this L001 is getting displayed. So what I'll do is I'll click this line, or whichever line number I want to extract the ISO. I'll click this line and I won't change anything, except I'll click here as well, check here as well, like to override the existing part. And this is the ISO style. I think you don't have to check anything apart from this. You have to just click the line, overwrite the existing, and just create. And it will take some time depending upon the speed of your system to generate the ISOs. Okay, as you can see, my ISO is ready. So I'll just click this message here, and we have this ISO location displaying here. I'll just click on this, and we can see that ISO is ready. And this is the nozzle or discharge nozzle of the tank connected to tank 001, and the line you can see. And this is the end section of the nozzle, and as you can see, this our isometric is ready. So this is how we extract the production ISO. And next we'll check with our quick ISO. What happens in quick ISO is, for example, I have routed this pipe and I want a quick review of that ISO. So what I'll do is I'll just click the quick ISO and select the parts which I want the ISO to be displayed. For example, I want only till this end, so I'll just enter, click create, or just not this, overwrite if existing and create. And as you can see, my isometric is ready. I'll click this and done. As you can see, it has just created the selected part, ISO of the selected part, like which I had selected. One is from discharge till the end of the elbow. So this isometric is just for reviewing purpose. And at the end, what you have to do is production ISO is used for manufacturing the spools. Then this quick ISO is just for reviewing purpose. Okay guys, so this was all about the isometric extraction. And now let us just have a brief look about the piping GA. Creating the orthographic views of our piping system. Okay guys, so let us start the final part of this video, that is the piping GA extraction, that is the ortho views extraction. So first what we have to do is we create a file. So for that you have to creating the orthographic views, you have to go here, click on the orthographic drawing tab, and here you have the orthographic drawings. Here just create a new file. I create tool test ortho. Okay, so my file is created with the standard template. So to create the orthographic views, we have some new commands in the ribbon bar now. So what I'll do is I'll create new, click on new view and select the file where I have done my piping, that is in the structure. I'll click OK. And you can see we have a green box on our piping system. So whatever present in this green box will be covered in our orthographic views. So as you can see here on the top left side, we have front, top view, whichever view you want. For example, if I click on top view, the red color of the green box will go on the top. And if I want the front view and click on the front view, you can see the red part comes on the front side. So whichever is red and whatever you're seeing from that red side will be displayed on your orthographic drawing. So right now I want the the top view. I'll click on top. So here it's on the top view, and also you can crop this view. For example, if you want the view only till this part, from the ground floor till this below the 6 meter floor, so I can just crop it. I'll just crop it, and here we have different options, like if you want the hidden lines to be shown and the hidden items to be shown, you can select hidden line piping. So for now I'll select the hidden line piping. If you want the hidden lines not to be shown, you can select no hidden lines, or to show all hidden lines. It depends on whatever you want. I'll just click on hidden line piping, and I'll just set the scale for for my orthographic cues. So I'll just take it as 1:30 and press OK. And when I come on the screen, I'll have to just select where I want to place the view. So I select randomly on this sheet, and my view is getting created, and it is done. As you can see, we have the 3 pumps, we have a tank here, and in this view you can give whatever the details you want. For example, if you want show the reference dimension from the axis, then if you want to show the line number, you can right click, go to Ortho Annotate, Piping, then you can see here line number call out, and select the line. You can see the line number is being called out. And next if you want like a full line number call out, you can select here, select the line, and you can see the size, line number, and the spec is being called out. And next, if you want to give the tag of this equipments, you can select, right click, Ortho Annotate, equipment and equipment tag. Click on the equipment and you'll get the tag P1003. Right click, Ortho Annotate, equipment tag, right click, Ortho Annotate, equipment tag. As you can see, this is how we can give the equipment tags. Then if you want to give the bottom of the pipe, the distance of the BOP, you can select, right click, Ortho Annotate, BOP, select the pipe, and it will show you the BOP of that line. Place that. And next, if I want the front view, what I can do is, if you can see, we have an option of adjacent view. I'll click on the adjacent view and select the current view, that is the top view which I have here. And next, whichever view I want, I'll just select that. For example, if I want the front view, I'll select the front view and just place it. See, and we got the front view of the same item. So here also, if you want to give the distance of center of the pipe till the bottom of the floor, you can give, and whatever details you want, you can give it here. And so guys, this is how we create the orthographic views of our piping system. And again, if you want an isometric view, you can just click adjacent view, then southwest probably. This is okay, and we don't have space in this, so I'll just place it outside. As you can see, so this covers our isometric view. So if you want to increase, like cover the whole plant, you can just go here, edit view, and this box, you can just expand the box so that it covers the whole plant. And if you press OK, and it will cover the whole system, whole piping system. So guys, this was a brief discussion about like how you do pipe routing, isometric extraction, ortho generation, and everything basic which you required, for clearing your tool test. So if you have any doubts, any minor doubts, you can just comment in the comment section, so I will clarify them if I can in the comment section or in my next videos. So guys, thank you for watching this video, and please subscribe to my channel and like this video and share this video with your friends who are in need of this type of videos. And thank you for your patience, and all the best.